And welcome everybody to the Daily Space Weather. We're looking at sunspot 2824 here as it rises to the scene. Great Earth scale there to show that this sunspot's umbra is about the size of the Earth, a little larger than the diameter of Earth. It's already a beta class sunspot, and we've seen a C-class solar flare out of it already. Here it is in 304 angstroms. The last one was 1700 angstroms from the Solar Dynamics Observatory. Great view of that C-class flare there. It's the brightest flash you'll see. Lots of stuff going on. Geomagnetic unrest has already arrived, and we're expecting a geomagnetic storm today, 2 coronal mass ejections to arrive at the Earth geospace, as well as an incoming coronal hole wind stream, so lots of stuff to cover on the Daily Space Weather. Sunspot 2822 setting in the northwest, and some activity in the south as well. Here's some more close-ups of sunspot 2824. This is 131 angstroms. And let's go back to the 304 angstroms again. It's spectacular. And again, that is a C-class flare you see there, the brightest little flash there, right there. And here's 193 angstroms. Another one of the UV emission spectral states of ionized iron. Fantastic filamentary imagery there also. Up here. And let's look at some more data here. Here's where things are located in the solar system. And we'll advance this 1 week. Looks like about 8 days until the next full moon. There's where we expect things to be in a week. Counting down to the solstice, we'll be doing something special. We'll be doing a live stream at the moment of the solstice. What will you be doing for the final month of spring, or if you're in the southern hemisphere, autumn? Here's a star chart if you're wondering what's going on above your head, as I am regularly. Check out in-the-sky.org, put in your location. I like to face my star chart to the south, as that's where the ecliptic's located for those of you in the northern hemisphere. 10.7 centimeter radial flux. Up to 75, still surprisingly low, but there is the 1-year chart of the 10.7 centimeter radial flux. It's this black line, the most proportional feature of solar activity to sunspot number, which is the red line. And don't take our word for it. You can find that graph at solon.info. So here you can see the geomagnetic storm forecast to come in a couple of hours here. Expected to arrive around between 9 and 12 universal time here. NOAA forecasting a G1. I wouldn't be surprised to see a KP of 6 from this. And again, there are 2 coronal mass ejections sort of expected to arrive at the same time here. And yeah, it's northern hemisphere summertime, folks. So the north should get struck a little harder than the south here. And let's take a look at global seismicity. We're usually wondering which earthquakes are erupting and where, and we're seeing a lengthy lull here in 7 magnitude quakes. You can see no 7 magnitude quakes here since March 20th. That's the 90-day major quakes, as reported by volcanodiscovery.com, who's got fantastic tools such as this tool, which allows you to sort by magnitude. And the most significant quakes that have been occurring in the past 24 have been happening here in Oceania, north of New Zealand. 3 5+ magnitude quakes there in the past 24 hours. Also 1 in the North Atlantic. We'll get to it. Let's scroll up the list. Starting with this deep quake in Russia, a 4.3 at over 380 kilometers estimated depth. Also a deep quake at Chile. That was a 4.1 magnitude at over 120 kilometers depth. Also, Japan saw a deep quake. Vanuatu saw a deep quake. Those both in the 4 range. And an aftershock there at Vanuatu at a similar depth. probably just one quake, as those occurred at the same time. And I'm just going to let the list scroll here. Leave us a comment if we've missed anything that you would have preferred that we covered. And there, that is a 4.8 in the Reconnaissance Ridge. Continuing on, Kilauea is erupting, and it's effusing into a lava lake. Kilauea, back on the list at volcanodiscovery.com. Fuego exploding in Guatemala, 16,000-foot ash plume above it. Sangay, 23,000-foot ash plume above it over Ecuador as it explodes as well. 23,000-foot plume of ash is nothing to attempt to hang glide over. Revenador, no volcanic ash clouds observed. Please do not square dance around the caldera. Sabancaya exploding. Please do not attempt a back handspring over the caldera there, as it's producing a 25,000-foot plume of volcanic ash, and possible emissions of volcanic ash from Nevados de Chilean are a reminder to not pole vault the caldera. Don't do a Steve Stimpak and pole vault the caldera. No matter how cool you might think you'll be if you make it, it's not worth the risk. So don't pole vault the caldera. This public service message brought to you at great personal risk and expense by smAsho.com. So here you can see this C-class solar flare that happened in the past 24 here. Peak flux was at just about 2 o'clock. And we're actually seeing some flaring kick off as we make the video today. A B-class solar flare happening as we record. So, and we can expect additional solar flares out of Sunspot 2824 as it is officially beta class. Whether you heard it here first, I don't know. No spikes in the proton flux, and we're not really expecting any, as the coronal mass ejections expected to arrive are fairly slow-moving and fairly diffuse. Next, looking at some magnetic data. Here's the GOES magnetometer, and we see a vertical line here almost. So a little pulse there right around midnight local time for the satellite. If you're new to the channel, you may not be aware that the N's and M's stand for noon and midnight local time for the satellite. So if you're wondering what those mean, that's midnight for the GOES 16 and that's noon for the GOES 16. And expect some sawtooth spiky patterns in this going on for the next day or two here with the arrival of a couple of coronal mass ejections. Next, let's look at the heliospheric current sheet. There is a North Pole current sheet approaching Earth. That's shown in green. Currently, the Earth is in a red heliospheric current sheet. Here's another view from the line of sight perspective. I would also note this dip in this blue line here. That's the location of the B field. And that's showing us whether or not it's north or south oriented. When you see it dip down like this, that's an indication that a North Pole current sheet is on the way. Here's another view. This shows you the sun's B field in blue. Coronal holes rotating just past the Earth-facing zone there. We can expect a high-speed wind stream from that coronal hole system. Arriving sort of at the same time as the coronal mass ejections. We see some signatures of that as well. And we should see that in the real-time solar wind. We'll get to it momentarily. First, detected filaments and sunspot groups. And while this is still showing sunspot 2824 as an alpha class, I assure you that there are some South Pole-oriented umbrae trailing that large North Pole umbra. And there are still some filaments in between Earth and Sun as well. Possibility for coronal mass ejections is still there. Not super high. And here's the geomagnetic situation here. Current situation is a state of geomagnetic unrest. KP index at 4. Next, the real-time solar wind. And it's fairly uneventful here so far. We did see an uptick in the solar wind density here. This looks like a coronal mass ejection strike, actually, folks. You can see the bottom pane there, the temperature, as well as the speed and the density all came up at the same time there, also coinciding with a shift in the BTBZ. So that looks like the first little bit of ejecta from the coronal mass ejection. One of the two coronal mass ejections. It's pretty weak and glancing so far. And then we see an uptick in the density and a downtick in the velocity. Anyway, current conditions are 9.77 protons per cubic centimeter for the solar wind density. Solar wind speed, 382 kilometers per second. Nothing major so far going on, but enough magnetism to create a geomagnetic unrest condition. So here we've got a very limited data run here and a bunch of missing data on the geospace magnetosphere movie. It should be 4 hours of data, and today it's got missing parts. So we're looking at 5:42 universal time to 9:05 universal time. But there are some missing sections of the run here for some reason. And we also see the same missing data in the ground magnetic perturbations, the other geospace magnetosphere movies section. And we're showing you the polar view here to give you the data that we have access to. And we do see some significant magnetic perturbations here. Here's another view, the global map. And let's see if we have any auroras kicking off as a result of the current state of geomagnetic unrest. And we can expect to see this intensify a little bit toward the end of this run. Let's see what we see. Surprisingly low aurora forecast there. Now, we do regularly stream live to Twitch. Today we're going to stream live to Twitch. And welcome to our Twitch viewers. We've decided to stream live for you. It's our cosmology segment. Thanks to our followers over on Twitch, twitch.tv/smAsho. Thanks to our new and loyal YouTube subscribers. Thanks for tuning into the Daily Space Weather. Check out our playlists as well. We do lots of stuff besides space weather. Also on BitChute, thanks to our subscribers over there. Cheers. Welcome to the Neo-Renaissance. Visit our websites, smashomash.com, smashomash.org will redirect you. Check out our merch, perhaps. Today's cosmology segment has got a series of interesting stories, as usual. Supernova remnant G53.41 plus 0.03 investigated in detail. What's up with it? I'll tell you what's up with it. It's got a half shell sort of a structure to it. So it looks like it's emitting in this way, but down here, nothing. So it's a half shell type supernova. What would cause a binary star system to do such a thing? Well, ultimately the answer is we don't know. But I'm just going to scroll the article here in case you'd like to read it. It's on phys.org in the Astronomy and Space section. And this is a multi-telescope project, including the XMM Newton and the LOFAR. Perhaps have a read about that. An interesting supernoval remnant with a half-shell structure. And if you've got theories why, let us know in the comments. Today's random number generated is 26, which coincides with an object over at the Neil Gorell Swift Bat X-ray Observatory. CF2, and it is a binary red supergiant catastrophic variable, an interesting star. And here's a paper about it, photometric investigation of the red supergiant catastrophic variable N-type binary, CF2. And you may find that older papers are very interesting, folks. This one's from 1995. You may want to check this out. And red giant type stars, folks, are extremely variable. They have a tendency to have stellar spots on them and so on. And, well, they're interesting. So perhaps have a read. Here's a view of CF2. This is on the Spitzer. Here it is on the 2MASS, another infrared spectroscope. And here it is on the XMM Newton. The red supergiant catastrophic variable, CF2, which is, again, entry number 26 at the Neil Gorell Swift Bat X-ray Observatory. Follow your favorite objects over there, at least their X-ray outputs. And there is the historic graph, the last 16 years of variability from CF2. Here's the 30-day chart of X-ray output from that. And today's astronomy picture of the day is the Necklace Nebula. And I would take this opportunity to show you a very interesting feature. So the main feature of the Necklace Nebula, folks, is the torus. So this is a prime example of a torus. And you can see this is probably in line with the equator of these two stars at the center of this nebula. But what's more important is this and this. Why? Those are the poloidal jets. And those areas right there are where the material coming from the jets has slowed down sufficiently to become visible. In other words, in between the center of this and where these jets are condensing, there is high-speed material making its way out to this area and beyond. But it's a great example of the poloidal fields, which would be oriented like this, versus the toroidal fields, which are a net result of the overlap of these two fields. You live in a toroidal field. The sun's poloidal fields are associated with its activity. Anyway, that's today's astronomy picture of the day. You can go find it yourself at apod.nasa.gov. And that's today's cosmology segment. Oh, we've got one more feature. I almost forgot. The Proba 2, the solar orbiter, rather, has released some images of coronal mass ejection. So on February 10th, I thought it was February 12th, but in any case, the solar orbiter took some imagery of a coronal mass ejection. Yes, on February 12th. So here is a little tidbit of that. And you can find this article at phys.org in the Astronomy and Space section. I'll just let that play. And you're looking at a composite here. It's the Proba 2 as well as the SOHO. So we regularly look at the LASCO C2 and C3, this is the LASCO C2. And this is the LASCO C3. The coronagraphs that we show regularly on the channel. Studying CMEs. It seems like an appropriate day to talk about it. Cheers. And that's today's cosmology segment. We'll have to say goodbye to Twitch. We'll bring you back for the meteorology and climate segment. Continuing on with the daily space weather. Here's a diagram of the Van Allen belts. Feel free to pause the video. Now, electrons out there in the Van Allen belts have the ability to charge up satellites. And we do see some charging hazards here, mainly over Central America and a little bit over the Central Atlantic and Central Pacific on either side of Central America. Here's a 1-year chart of the electron flux. The greater than 2 mega electron volt electron fluence. Here's a 3-day chart. And this may be all over the place here, as again, there's a coronal mass ejection and some coronal hole wind showing up all at the same time. NOAA is forecasting a continued increase in the relativistic electron flux. No argument from me there. It's happened before. It wouldn't be surprising. We see chaotic belts of electrons. Here's the total electron content forecast, and you're going to see large, dense blobs of electrons at nighttime over places like Africa and the Central Atlantic. I'll let it play through a second time here. The total electron content forecast shows you the entire air column from your GPS satellite to your handset. GPS errors happen most frequently around the equator at noon, and you're more likely to see one in the summertime than in the wintertime. Here's another diagram of the atmosphere, since we're going to show you the ionosphere next, the ionogram. And the F ionosphere is located at about 300 kilometers, as you can see in the diagram there. And here's the 2-day ionogram. So you're looking at 2 hours per second here. The 2-day ionogram, this is going to be the new format for the daily space weather. And this may show you some anomalies, such as those over South America there. You can see the ionosphere kind of dipped down towards South America. Keep in mind there is a South Atlantic anomaly also, folks. The 2 weakest portions of the Earth's magnetosphere are about here. And there's a second one down here, the South African anomaly. And you can actually see evidence of where those are located by curves on the ionograms there. Great example of that on today's ionograms. Let's bring up the latest image here. It's at 8:30 Universal Time. Things looking pretty normal at that moment. And let's get into the realm of meteorology. And since we've entered into the realm of meteorology and climate, welcome back, Twitch. Check out the von Karman clouds near Guadalupe Island. Some swirling clouds here. Check this out. So that's Guadalupe Island there, and you've got this wind flowing past it, creating these vortices on the leeward side of the island. Great example there of some weather pornography for you. You can find this on AccuWeather.com's news area. Some stunning von Karman clouds captured by satellite. Let's take a look at the jet streams. First, the surface winds. Here's what's going on in terms of surface winds in the western portion of Earth. Here are the jet streams, and completely chaotic jet streams here over most of the U.S. And it's creating some turbulent weather and some massive flooding risks. We'll get to it. First, the jet streams of the eastern world. There are those. And here are the surface winds. And this tropical cyclone has made landfall here on India now, actually, so we can expect that to weaken, fortunately, as some death and destruction have been resulting from that. Next, looking at lightning maps. I like to use lightningmaps.org when I hear thunder. And it looks like we've got some terrestrial lightning here. Large portions of Texas. Hey, Lubbock, get outside and look to your southeast, your south-southeast. Anyway, that's some of the most intense lightning on Earth right now. Also down here near Corpus Christi. Some thunder looks like it's rolling in there as well. Anyway, there's your global lightning map. Here is your visual analysis of it. Very strong lightning here over the Oklahoma Panhandle and much of Texas. Also Louisiana seeing some strong storms there and some heavy lightning. Let's talk about climate. Greenland is melting, folks. Greenland is melting. Now, it's summertime in the northern hemisphere. And in the summertime, the snow that fell in the wintertime melts. That's what happens. Now, Greenland, around the solstice, a large portion of Greenland is lit all day long. And it gets very hot in Greenland. And when you have a lot of snow, guess what happens? You have a lot of melting. So here's a lovely alarmist article on phys.org in the Earth section. Part of Greenland ice sheet may be close to tipping point. And we cover this each summer as we see ridiculous, nonsensical articles trying to cultivate fear and suggest that, oh noes, Greenland is going to melt and it's going to cause global sea level to rise by 7 meters. If you're scared and spooked about this, if you're frightened, leave us a comment and let us know. Let's take a look at some data. So, here is the snow mass, and it's funny because they actually talk about snow mass balance. Let me read the paragraph here. An ice sheet can only maintain its size if the loss of mass from melting and calving glaciers is replaced by snow falling onto its surface. The warming of the Arctic disturbs this mass balance because the snow at the surface often melts away in the warmer summers. Well, let's see how much it's been snowing in order to melt. Oh, look, it's 2 standard deviations above normal snow mass balance for the past 4 consecutive winters. So here's the past winter, and you can see how outside the 30-year average that is. The blue shaded area would be the 30-year 1 standard deviation range, and you can see it's clearly 2 standard deviations above the normal range. Snow extent is also right at the 20-year average there, at the 1 standard deviation above the 20-year average, rather, as those blue lines are the plus to minus 1 standard deviation. And lastly, here is the snow water equivalent, which is also more than 1 standard deviation above normal. So we're going to hear articles all year probably about how, oh noes, Greenland is melting. So let's just cover it. Let's see how melted Greenland is, shall we? So up here, oh my God, how much snow? Only 8.7 inches there. Oh, 12 inches there. Okay, all right. Look at this. Oh my God, 0 inches. Okay, let's go farther inland. How about here? More than 5 meters, more than 5 meters, more than 5 meters. But only 0.3 inches there. Oh my God, case closed. Greenland is melting. It's time to be very frightened, folks. I'm very, very scared. Are you frightened that Greenland is going to melt? Oh no, sea level could rise 7 meters if Greenland melts. I'm very, very scared. Again, leave us a comment. Let us know how frightened you are. Let's take a look at pressure. Oh look, a massive anticyclone with a clockwise rotation taking place over Greenland. Anyway, here's where pressure cells currently are. Powerful low pressure there over central Canada. And we'll advance this into tomorrow. There's where we expect things to be according to the European forecast for pressure at 12 noon daylight time tomorrow. 12 noon Eastern Daylight Time. High pressure overhead. We're expecting clear skies over the mid-Atlantic. Next, looking at the total accumulated precipitation forecast here. This is the GFS forecast from Tropical Tidbits, and we are still seeing a forecast for like 20 inches of rain now in Arkansas and northeastern Texas, and also a bit in extreme eastern Texas. So that's through 12 Universal Time, 12 Zulu Friday. The GFS forecast for rain there. Some extreme precipitation in the forecast. Let's take a look at the current Doppler radar map, and you can see strong storms here, Louisiana, Texas, Oklahoma, and Kansas. Hopefully nobody being delivered to Oz. Here's what's going on in the cloud layer. And we've got stagnating systems and massive pressure gradients. So you've got this dry mass of air right here in between these two blobs. In between these two blobs of moist air. Did I just draw something vulgar? I'm terribly sorry, folks. Anyway, again, there's the cloud layer. Here's the Doppler radar. And when the Doppler radar is not giving you sufficient information, folks, check out the NASA GOES Interactive Weather Satellite Suite. The water vapor map does not allow water vapor to hide. So we're going to zoom in on this area here at the Louisiana-Texas border to just get you a little bit more zoomed in on this couple of atmospheric ponds that have formed over the U.S. It's a couple of atmospheric ponds, and they're taking their time to move because the jet stream is nowhere near there. So a great view of those two systems there. Again, there's the cloud layer, there's the water vapor, and they're just stagnating as that dry mass of air is just hanging out. And that is why there is so much moisture. And one more time, there's the Doppler. There is the cloud layer. And there is the water vapor map. And that's today's meteorology and climate section. I've been your host, Dan, a.k.a. smAsho, and we'll see you later, Twitch, as bonus features continue on The Daily of Space Weather. First bonus feature is the Lermuth ground-based solar observatory. Located in Lermuth, Australia. And there are some clouds there, which is what that flashing is. And a bunch of filaments there north of sunspot 2824. Again, likelihood of additional solar flares. There was actually one going on when we did the show. Let's see if we It was just a small B-class flare, folks. Anyway, there's the view from Lermuth. Again, there are filaments, especially in the eastern portion of the sun. Some in the northwest as well. So there is a significant possibility for additional coronal mass ejections. Don't be surprised to see that. Don't be surprised to see more large solar flares, especially out of sunspot 2824. Thanks to our patrons, the true source of funding for the content. If you'd like all kinds of perks, consider becoming a patron at patreon.com/smashamash. Thanks, patrons. You're increasing the probability that these videos will continue to exist, that will release a paper about the mechanism associated with the solar cycles, and you'll keep us forecasting coronal mass ejections before they eject. Here's what we saw during show prep. Sunspot 2824. There it is in magnetogram. Let's press refresh to see how it's evolved in the past approximately half hour. And you can see those trailing umbrae there. It's beta class, but just barely, as the trailing south umbrae are quite small, but those are indeed South Pole-oriented umbrae. You can see them in red. And we'll close things out with a couple more views. Here's 94 angstroms. Another SDO wavelength here. This one takes 10 images per minute instead of only 2, like 131 angstroms. And here's my personal favorite, 171 angstroms. Perhaps we'll be making another video later today, folks. Thanks for tuning in to the Daily Space Weather. And may that solar wind be at your back.